नमस्कार साथियों। हेलो। नमस्कार साथियों। नमस्कार साथियों, फिर से स्वागत है आपका हमारे चैनल में। क्लास 8 की जो साइंस की सीरीज चल रही है, उस सीरीज में आज जो हम चैप्टर देख रहे हैं वो चैप्टर है 12 और उसका नाम है सब नेचुरल फिनोमेना। तो चलिए आइए हम आज सीखते हैं कुछ नया सब नेचुरल फिनोमेना में। फुल एक्सप्लेनेशन मिलेगा आपको, बने रहिएगा मेरे साथ। जो भी नए लोग आए हो तो प्लीज लाइक कर दीजिएगा सेशन को, अच्छा लगे तो शेयर कर दीजिएगा और कमेंट तो बनता ही है, कमेंट में आप अपने फीडबैक जरूर दें। थैंक यू सो मच।
Lightning. You might have seen sparks on an electric pole when wires become loose. You might also have seen sparks when a plug is loose in its socket. And you must have seen the lightning with the thunder during heavy rains. Is lightning different from the spark? In fact, lightning is also an electric spark, but on a very large scale. Lightning is caused by the accumulation of charges in the clouds.
आपने वायर्स के लूज होने पर इलेक्ट्रिक पोल्स पर स्पार्किंग होगी। जब सॉकेट में कोई प्लग लूज होता है तब भी स्पार्किंग होती है। और आपने भी बारिश के दौरान लाइटनिंग और थंडर भी देखा होगा। क्या लाइटनिंग स्पार्क से भी
The comb attracts pieces of paper. Why? When a plastic comb or plastic scale is rubbed with dry hair, it acquires a small charge. The object is called as a charged object. When charged object is brought near the pieces of paper, it induces opposite charge in the pieces of paper. And the pieces of paper get attracted to the comb or plastic scale. So, we see that a body gets charged by rubbing. Lightning. You might have seen sparks on an electric pole when wires become loose. You might also have seen sparks when a plug is loose in its socket. And you must have seen the lightning with the thunder during heavy rains. Is lightning different from the spark? In fact, lightning is also an electric spark, but on a very large scale. Lightning is caused by the accumulation of charges in the clouds. In 1752, Benjamin Franklin, an American scientist, showed that lightning and sparks are essentially the same phenomenon. Types of charges. You must have rubbed comb on dry hair and brought it near to the small pieces of paper. What happens? The comb attracts pieces of paper. Why? When a plastic comb or a plastic scale is rubbed on dry hair, it requires a small charge, and the object is called as a charged object. When charged object is brought near the pieces of paper, it induces opposite charge in the pieces of paper. And the pieces of paper get attracted to the comb or plastic scale. So, we see that a body gets charged by rubbing. It is a convention to call the charge acquired by a glass when it is rubbed with silk as positive. When a charged glass rod is brought near to a charged plastic straw or refill which is rubbed with polythene, there is an attraction between the two. What do you think about the kind of the charge on the plastic straw? Yes, plastic straw carries a negative charge. That is why it is being attracted to the glass rod with positive charge. So, we can conclude that when we rub objects, electrical charges are generated. There are two types of charges, positive charge and negative charge. Interaction between the charged bodies. We know that charged bodies attract or repel each other. Why does this happen? In this module, we will study about the interaction between the charged bodies. Let us do an activity. Take two inflated balloons. Hang them in such a way that they do not touch each other. Rub both the balloons with a woolen cloth and release them. What do you observe? The balloons repel each other. Now, take a refill and hang it. Rub that refill with polythene. Take one more refill. Rub this also with polythene. Bring it close to the already charged refill. Be careful not to touch the charged end with your hand. Now, what do you observe? The refills repel each other. So, we see that a charged balloon repels a charged balloon and a charged refill repels a charged refill. This means that both the charged balloons have same charge and so repel each other. Similarly, both charged refills have same charge, so they repel each other. Now, once again, charge the balloon by rubbing it with woolen cloth. And bring a refill charged by rubbing with polythene close to it. What do you observe? They attract each other. Why does a charged balloon attract a charged refill? This is because the charge on the balloon is of a different kind from the charge on the refill, and so the opposite charges attract each other. So, we can conclude that similar charges repel each other and opposite charges attract at each other. The story of lightning. All enjoy rains, but sometimes when there are heavy rains along with thunderstorm, we see lightning and we get scared. What is lightning? How is it produced? We will answer all these questions in this module. Lightning is an electric spark on a huge scale. How is lightning produced? During the development of a thunderstorm, the air currents move upward and water droplets move downward. These vigorous movements cause separation of charges. The positive charges collect near the upper edge of the clouds and the negative charges accumulate near the lower edge. Also, there is an accumulation of positive charges near the ground. Air is a poor conductor of electricity, so it doesn't conduct these charges. But when the magnitude of the accumulated charges becomes very large, the air is no longer able to resist their flow. Negative and positive charges meet, producing streaks of bright light and sound. We see these streaks as lightning. The process is known as electric discharge. The process of electric discharge can occur between two or more clouds or between clouds and the earth. Now we have understood the basic phenomenon of lightning, so we need not get frightened by it. Lightning safety. We have seen many times that lightning strike destroys life and property. Then how to protect ourselves? In this module, we will learn about lightning safety. Do's and don'ts during a thunderstorm. During lightning and thunderstorm, no open place is safe. So, on hearing a thunder sound, rush to a safer place like a house or a building. If you are traveling by a car or bus, close the windows and doors of the vehicle. If you are in a forest, take shelter under shorter trees. If no shelter is available and you are in an open field, stay far away from all the trees. Stay away from poles or other metal objects. Do not lie down on the ground. Instead, squat low on the ground like this. This position will make you the smallest target to be struck. Lightning is an electrical discharge and can strike telephone cords, electrical wires, and metal pipes, so avoid them. It is safer to use mobile phones. Bathing should be avoided to avoid contact with running water. Electrical appliances like computers, TV, etc. should be unplugged. Although electrical lights may remain on. Lightning conductor. Are you surprised what these pictures are of? These are the damages caused by lightning. A lightning strike could destroy both life and property. It is therefore necessary to take measures to protect these using protective devices. Lightning conductor is one such device. A lightning conductor is used to protect buildings from the effect of lightning. In this module, we will learn about the lightning conductor. Lightning conductor, a metallic rod taller than the building, is installed in the walls of the building during its construction. One end of the rod is kept out in the air and the other is buried deep into the ground. This is called a lightning conductor, as it provides easy route for the transfer of electric charge to the ground. Earthquake. How earthquakes occur. An earthquake is a sudden shaking or trembling of the earth which lasts for a very short time. It is caused by the disturbance deep inside the earth's crust. The outermost layer of the earth is called the earth's crust. This layer is not in one piece. It is fragmented. Each fragment is called a plate. These plates are in continuous motion. When they brush past one another, or when one plate goes under another due to collision, they cause disturbance in the earth's crust. It is this disturbance that shows up as an earthquake on the surface of the earth. Tremors on earth can also be caused when a volcano erupts, or when a meteor hits the earth's surface, or when an underground explosion is carried out. However, most earthquakes are caused by the movements of Earth's plates. The boundaries of plates are weak zones where earthquakes are more likely to occur. These weak zones are also known as seismic or fault zones. In India, the areas most prone to earthquakes are Kashmir, West and Central Himalayas, the whole of Northeast, Run of Kutch, Rajasthan, the Indo-Gangetic Plain, and some areas of southern India. The tremors produce waves on the surface of the earth. These are called as seismic waves. Lightning safety. Earthquake, seismic waves and seismograph. The tremors produce waves on the surface of the earth. These are called as seismic waves. These waves are recorded by an instrument called a seismograph. This instrument is simply a vibrating rod or a pendulum, which starts vibrating when tremors start. A pen is attached to the vibrating system. The pen records the seismic waves on a paper which moves under it. By studying these waves, scientists can construct a complete map of the earthquake. They can also estimate the magnitude of destruction by studying these waves. The magnitude of an earthquake is expressed in terms of a scale called the Richter scale. Destructive earthquakes can have magnitudes higher than 7 on the Richter scale. Both Bhuj and Kashmir earthquakes had magnitudes greater than 7.5. Earthquakes can cause immense damage to buildings, bridges, dams, and people. They can cause great loss to life and property. Earthquakes can also cause floods, landslides, and tsunamis. A major tsunami occurred in the Indian Ocean on 26 December 2004. All the coastal areas around the ocean suffered huge losses due to that tsunami. Earthquake safety tips. We know that earthquakes cannot be predicted, but they can be highly destructive and dangerous. It is therefore necessary to be prepared all the time and take necessary measures to protect ourselves. The buildings in weak zones, seismic zones, should be so designed that they can withstand major tremors. The use of mud or timber is better than using heavy construction materials. The cupboards and shelves should be fixed to the walls so they do not fall easily. Since buildings may catch fire due to an earthquake, it is therefore necessary that all buildings, especially tall buildings, should have firefighting equipment installed in them. If you are at home during an earthquake, take shelter under a table and stay there until shaking stops. Stay away from tall and heavy objects that may fall on you. If you are in bed, do not get up. Protect your head with a pillow. If you are outdoor during an earthquake, find a clear spot away from buildings, trees, and overhead power lines and lie down on the ground. If you are in a car or a bus, do not come out. Ask the driver to drive slowly to a clear spot. Do not come out until the tremors stop. Transfer of charge. Let us do an activity to understand the concept of transfer of charge. Take an empty jam bottle. Take a piece of cardboard slightly bigger in size than the mouth of the bottle. Pierce a hole in it so that a metal paper clip can be inserted. Open out the paper clip as shown. Cut 2 strips of aluminium foil about 4 cm into 1 cm each. Hang them on the paper clip as shown. Insert the paper clip in the cardboard lid so that it is perpendicular to it. Charge a refill and touch it with the end of the paper clip. Observe what happens. We find that foil strips repel each other. Touch now other charged bodies with the end of the paper clip. The aluminium foil strips receive the same charge from the charge refill through the paper clip. Remember that metals are good conductors of electricity. The strips carrying similar charges repel each other and they become wide open. Such a device can be used to test whether an object is carrying charge or not. This device is known as electroscope. Thus we find that electrical charge can be transferred from a charged object to another through a metal conductor. Touch the end of the paper clip gently with hand and you will find a change in the foil strips. They come back to their original state. Repeat charging of foil strips and touching the paper clip. Every time you will find that the foil strips collapse as soon as you touch the paper clip with hand. Why does it happen? The reason is that the foil strips lose charge to the earth through your body. We say that the foil strips are discharged. The process of transferring of charge from a charged object to the earth is called earthing. Students, do you know, earthing is provided in buildings to protect us from electrical shocks due to any leakage of electrical current.
कागज के टुकड़ों के पास लाए होंगे। क्या होता है? कोम कागज के टुकड़ों को अट्रैक्ट करती है। और क्यों? जब किसी प्लास्टिक कोम या प्लास्टिक स्केल को सूखे बालू के साथ रब किया जाता है, उस पर थोड़ा सा चार्ज आ जाता है और वो चार्ज्ड ऑब्जेक्ट बन जाता है। जब चार्ज्ड ऑब्जेक्ट को कागज के टुकड़ों के पास लाया जाता है, तो चार्ज ऑब्जेक्ट कागज के टुकड़ों पर ऑपोजिट चार्ज इंड्यूस करता है, तो पेपर के पीसेस कोम या प्लास्टिक की तरफ अट्रैक्ट हो जाते हैं। तो हमने देखा कि बॉडी रबिंग से चार्ज हो जाती है। ये मान्यता है कि ग्लास रॉड को सिल्क से रब करने पर ग्लास रॉड पॉजिटिवली चार्ज होती है। जब चार्ज ग्लास रॉड को किसी चार्ज प्लास्टिक स्ट्रॉ या पॉलीथीन से रब रिफिल के पास लाया जाता है, तब दोनों के बीच में अट्रैक्शन होती है। आप क्या सोचते हैं, प्लास्टिक स्ट्रॉ पर कौन सा चार्ज होगा? जी हाँ, प्लास्टिक स्ट्रॉ पर नेगेटिव चार्ज है, इसीलिए ये पॉजिटिव चार्ज वाली ग्लास रॉड की तरफ अट्रैक्ट होती है। तो यहां से हम निष्कर्ष निकाल सकते हैं कि जब हम ऑब्जेक्ट्स को रब करते हैं, तब इलेक्ट्रिकल चार्जेस जनरेट होते हैं। दो प्रकार के चार्जेस होते हैं, पॉजिटिव चार्ज और नेगेटिव चार्ज।
Interaction between the charged bodies.
क्विज करो जल्दी, जा वो। वेरी गुड, नेक्स्ट। वेरी गुड, नेक्स्ट। नेक्स्ट।